Hey, Keith. Thank you so much for that introduction. Appreciate it. So, hey, folks, I'm DJ Singley. I'm the chief architect here at MAPSYS. MAPSYS is a platinum IBM business partner. We do staffing, we do software sales, we do maintenance sales, we do software design and development, and of course, hardware sales for both data center and client. So we do it all, right? We're an ESOP. That means every single employee at MAPSYS owns the company, and that means we have a greater investment into making sure that our customers are ultimately successful and very happy, because that is our success and clearly our happiness too. Listen, before I get going on this, why don't you all take just a second and find me on LinkedIn? It's really easy. I have a very unique first name, Daneyand, and if you go to point your browser at daneyand.com, you can find me. It goes right to my LinkedIn page. That way we can stay connected. I post some articles here and there and videos as well on interesting technology topics, and the next couple of them are on IBM Power 10 or Power in general. And I think you folks will find them very interesting, especially the IBM I folks in the coming couple of presentations I'll be posting on there. Although I have not done them yet, I'm just about to finish them up. I just got to click publish. So stay tuned for those. They're coming up soon. So today's webinar, we're going to talk about Power10 Scale-Out hardware and actually the entry-level enterprise system as well, plus a little bit of IBM storage update. As many of you know, Power10 debuted on the 12th of July this year, or at least I should say the scale-out models and the entry-level enterprise models debuted on July to the 12th. So we're 2 or 3 weeks into it now, and man, I'll tell you, it's been a fun ride so far. There's a lot to know about Power 10, and we're going to do sort of a deep dive as far as we can into the technology today. And my promise to you folks is that if you'd like to see more of it from MAPSYS, from myself, from the rest of our company, we would love to explore this with you at some point. But with that said, let's take a look at some Power 10 systems and the reasons why we even use Power. All right, I have to throw this up there because I think this is uniquely important for Power systems and IBM servers. As many of you already know, when you've visited my LinkedIn page, I was a power designer when I got out of college in the early 2000s for about 6 years. I have several published papers on microarchitecture design and programming techniques, plus patents as well. And so I love power, right? And for the last 13 years or more even, this consulting organization, the ITIC, have been ranking the reliability of server vendors, various servers out there. And as you can see here, right, this slide here represents the minutes of downtime per year per server type, right? So generally, as a whole, over the last 13 years, all servers have gotten much more reliable. But as you can see here, still today, the very most reliable server in the entire world is IBM Power Systems with Linux or AIX. Now, I know some of you will be saying, hey, wait a second, I'm an IBM I or AS400 user. Where's my favorite platform on here? And all I can say is the ITIC does not gather information for IBM I for whatever reason. It's a very unique, bespoke operating system, right? So that's why. But yes, of course, it would be probably exactly with the Linux and AIX result, or maybe even better. Now, my mainframe friends out there and some of my old pals that are still in mainframe design would probably put their hands up and say, hey, listen, I think we can beat that number. And I'm sure you can, but this is just talking about more of an open system design with Linux on readily available hardware. So that's IBM Power Systems. Now you can see the results here are actually quite good for a lot of vendors, right? But still, the best out there, the very, very best, is IBM. So these are the reasons why we run this platform, because it is more reliable, it is more available, and it is more serviceable than all of the competition. So IBM processors through the years have always been leaders in performance and reliability, availability, and serviceability. So here's the last 10 years or so of processor design with IBM. In 2010 or so, IBM's Power 7 Plus debuted. That was actually the very last chip that I got the pleasure of working on when I was in design, the very early versions of that. So it's very near and dear to my heart. But a Power 7 machine with about 1.2 billion transistors on the 45 nanometer node from IBM or Global Foundries at the time was quite an amazing machine. every single generation, which is about 3 or 4 years, from each other, really looks to take a holistic approach to system design and keep your scaling at a linear level, meaning your performance will grow up linearly. Unlike the other guys out there, and guys and gals that may tweak a memory system here, therefore revealing a bottleneck over there, right? IBM system design is much more holistic in the entire system. So from 2010 to 2014, the Power 8 chip had a very linear progression from Power 7, Power 9 again on 2017. 2018, I should really say. 2017, a lot of those chips ended up going in the two largest supercomputers of the world, Summit and Sierra, which are still up there in the supercomputing ranks, although I think they're down to 2 or 3 or 3 or 4 in the ranking in the world right now. So they've slipped a bit, but they are older machines at this point. And now Power 10, again 3-4 years later, is bringing the heat again and the linear scaling back to the arena with 18 billion transistors on a 7 nanometer node. And this time we're at the Samsung foundry. So leaving IBM, leaving Global Foundries, going to Samsung. As many of you know, IBM did sell the foundry business to Global Foundries many years ago. Many years ago. I don't know, 5, 6, 8, 10 years ago. I don't even remember. It's been a little while. And then rest assured that in about 4 years' time or 3 years' time from today, Power Next, right, which is Power 11, I'm sure, unless they change the naming scheme somehow. And my buddies in Austin tell me that they're working on Power 11 and it's going quite well. They don't tell me anything about it. I'm not allowed to know, but that's what they're working on. So this is where we are with Power, right? This is a holistic approach to system design that ensures growth. So how does IBM stay linear? Well, I wanted to touch on a couple of things here real quickly because this is one of the only sections I'm going to actually talk about one really cool defining feature of Power 10 that most of you will probably not be interested in or use, but we're still going to talk about it because I think it's just super awesome. So ready? Total system design. We were talking a little bit about IBM using the total system design, not just tweaking one part of the chip, not tweaking the memory subsystem, not just adding more cores, but really massaging the entirety of the design so it works in concert and unity. That means keeping up with the latest memory technologies. That means keeping up with the latest I/O technologies, such as Power 10 being the first machine with PCI Express Gen 5. Of course, Power 9 was the first machine with PCI Express Gen 4, right? So IBM's always on the cutting edge of this stuff. And also adding new application-focused technology, such as AI instructions on the chip itself, which is pretty great. What that means is that you can do 16-bit B floats, 8-bit ints, and 4-bit ints for use in AI instructions. So a lot of these databases that are coming down the pipe, such as the Oracle databases and InterSystems databases and other things, even IBM DB2 will have some various AI models built in. And instead of going off chip to an accelerator to run those models, you can run them on chip. And that will cut down on cost, it'll cut down on latency getting the models run, and it'll give you your answer back faster. Okay, so that's why we do this on chip. And those instructions are just an example of some of these instructions that are available to the AI folks out there looking to speed up their workload here. Now, I know a lot of you might say, hey, what is a 4-bit int ever going to do for my AI? Well, all I can say is that AI models don't need the precision that other computing does, so it's actually does a lot. It speeds up the model, gets you your result faster, and you're off to the races doing other things, other parts of the workload. The other thing is memory inception. Again, this is something that's like out of a comic book, right? Many of you might remember that movie with Leonardo DiCaprio many years ago, Inception, right? Well, I feel like this technology is sort of like that. It is wild. Now, let me give you the 10,000-foot DJ explanation of this, and then why you probably aren't going to use it. So the first thing is that think of memory inception of a private memory network between power systems in a cluster such that they can share each other's memory. So 1L, power on machine 1, can share its memory with machine 2, or borrow machine 2's memory for a larger memory footprint. Think in-memory databases such as SAP HANA and other use cases like that. This could really be a game changer. It sounds great. The thing is, it's not part of the product line today, right? So you cannot buy this machine, any of these machines, and run memory inception today. It just doesn't exist. It will exist. It doesn't today. So most of you probably won't be using that today. Some of the larger customers, I'm sure, will be really looking forward to this in the future, and maybe even cloud providers such as IBM Cloud or even smaller clouds that can buy memory-rich servers and share that memory among any of the nodes on the memory inception network. So that would be really neat. The last thing we're going to talk about is IBM's continued progression and forceful push of security in the microprocessor designs, along with reliability, availability, and serviceability. And the very first bullet point here, I think, is very prescient, right? IBM has decided to use memory encryption on the Power10 product line, as well as the latest Z16 mainframes, right? These are the first products on the market that use memory encryption. The memory is encrypted all the time, even in the caches. So things like Spectre and Meltdown may be less of an issue on Power10 than it is on other architectures. So again, IBM maintaining that overall security leadership by a very large margin at this point. And of course, increasing the reliability, availability, and serviceability of these products in the market. So let's take a look at what Power10 looks like. Okay, well, I wish I could see a show of hands right now of who has seen a slide like this in previous product announcements, because I think every one of you would say, yes, we've seen it. So this is the Power10 version. I think it's better because it gives you relative performance instead of engineering words like 2 or 4 or 24 more floating point units. Who cares? How much better is it at processing your business instructions and getting the workload done? I don't care how many floating point units. Do you folks? I didn't think so. So great chart, I think. In general, you can expect around 30% more performance for Power10 relative to Power9. So that's a nice jump. Again, you can see here in the middle here too, as we can read it, right? 20% more performance for thread strength. There's a lot more various units like crypto engines. That's a bigger deal with modern workloads. AI focus is a big deal here when you'll see more single instruction, multiple data. That's the SIMD that they're talking about, general and matrix SIMD. Think vector instructions and all the AI instructions for AI inference workloads, like in databases and other things. So big deal. And of course, a renewed focus on energy efficiency in Power10 compared to Power9. Now, if you look at the picture here, there are clearly 16 cores on this chip. IBM will productize the most at 15 cores. That last core is probably just abandoned due to yield reasons, et cetera, et cetera. Also, you'll be able to buy lower core count versions for various reasons, and we'll get into what that looks like here in just a bit when we look at the systems. If you look around the outside, that's the robust data plane. That's all the signaling off chip, such as to support memory inception, which we just talked about. 2 terabytes per second of raw bandwidth off chip for memory memory obsession, memory inception over the power axon and OMI signaling. So that's a big deal. That's a lot of memory bandwidth off chip. Also supports the SMP interconnect between sockets, up to 16 sockets, which is a big deal, and PCI Express Gen 5. I will point out as well, because I think this is a big deal, and we'll talk about next slide, the memory signaling OMI, the Open Memory Interface. So Power10 is not bound by the rules of DDR4 or DDR5 or GDDR6 or any memory technology. It is obfuscated behind this Open Memory Interface, and that allows IBM designers and server designers to use any memory standard that they deem necessary or economically feasible, which you'll see. And we start out the product line here with DDR4. So what other reliability, availability, and serviceability standards and innovation does IBM bring with Power10? Let's take a look. So whenever IBM does a design, they literally have a mathematical formula that they use to gauge the reliability the availability and serviceability, the RAS characteristics of the design. And Power 10 is no different. So let's take a look at some of the things that make Power 10 or Power in general a much better architecture than the competition. So the very first one here, right? Redundant system cooling with multiple fans and concurrent maintenance. Oh, right. That does not sound like it's very exciting. That sounds like everyone in the world does it. Yeah, I think you guys are right. Everyone in the world does do that one. What about redundant bulk power? Even if 2 power supplies fail, system keeps on operating in 4U systems. Okay, that's great. That's kind of table stakes, though. So thanks, IBM. Great. What about number 3? Aha, this is where the meat of it is. You see what the 3 little label is over the processor chip or the heatsink of the processor? Yeah, that's just to say, hey, all the magic happens in the processor, and it certainly does. So let's take a look at a couple of these things. So IBM uses a technology that they deem first failure data capture, FFDC. And this is wild. No other architecture that I'm aware of does something like this. So what that is that there was a bunch of checkers, and that is actually an engineering term that sort of dates me back in the day, checkers in the processor that look to see if any operation completed successfully. If they deem that operations haven't succeeded successfully, they stop. They capture the machine state, the entire machine state. They read it out, give it to the HMC, the hardware management console, which then sends it up to IBM engineering and the support structure at IBM. First failure data capture is a big deal. It allows us to realize when there's a problem with the machine and then to potentially correct for the problem. So the first thing it will do is the next thing that it's written there, instruction retry. It'll retry the instruction. Did it fail or did it succeed? If it succeeded, okay, maybe that was a transient error, an alpha particle coming from space, whacking the register, and there you go. It failed because of that. But if it did fail again, that's when we do a core contain check stop. We contain the failure to that core. We read out the exact machine state, and we can do other really neat things like read that machine state into another core in the chip, somewhere in the chip or in this whole system, and restart those transactions, restart those instructions to have them finish. So all these are innovations I've never seen anywhere else on any other processor. Now, maybe, admittedly, I haven't been paying attention to some of the competition, but this is such a big deal that IBM is certainly tops when it comes to this type of technology. In addition to that, power and cooling monitoring, multi-node SMP fabrics, that's all nice, but the bulk of the impressive engineering here comes with the first couple of things we just talked about. When we look at 4, the chip kill technology, the memory that we use in IBM Power 10 is not industry standard anymore like Power 9. It is now an IBM proprietary format, and it provides much greater redundancy reliability. We'll take a look at what that is in just a moment. And then active memory mirroring for both hypervisor and workloads. So what that means is it's kind of in the description, I suppose. What it means is you can mirror your memory throughout the entire system. So if one memory card fails, nothing happens. Everything's great. IBM will eventually come by and swap out the card. Or you can mirror just your hypervisor memory. So that would take a lot less memory to mirror your hypervisor memory, typically about 15% of your total memory. And if a memory card were to die, only the LPARs contained on that memory card would go down, which would then hopefully be restarted later in some other machine or on the same machine if it has extra resources to restart them. So that's a big thing. We've used this to great effect in a couple of different workload scenarios with Power 9. So I'm glad to see it really in the entry-level space on the Power 10 processor. So it looks great. So I've talked about the open memory interface in a previous slide. Well, it's a big deal, right? IBM ensures that the memory subsystem of the Power 10 has much better RAS characteristics than the memory interface of the previous generations, Power 9. And that's what they're shooting for here. Let me introduce you to the differential DIMM, and I'll show you what that looks like in the next slide here. The differential DIMM is IBM's proprietary memory packaging. Right now it's a DDR4 3200 megabit a second module with 409 gigabytes, that's right, gigabytes a second per socket. That's a lot. Using the open memory interface, that's how we're going to connect to these DDIMMs. They offer 2x better RAS and even higher memory bandwidth than the industry standard DIMM technology that other vendors use. So big plus here for IBM. We talked a little bit about active memory mirroring. That is a big deal for sure on higher priority workloads. But the other thing that IBM does with this memory technology now, finally with Power 10, is they do something called transparent memory encryption. And it is exactly what it sounds like. Memory is always encrypted. So vulnerabilities that affect other architectures, such as Spectre and Meltdown, may not have nearly the sting on a Power 10 type of environment than they would other competitive environments. So that's a big deal. The only other server out there that encrypts memory is the Z16 mainframe. You got it. I'm sure a couple of you were thinking about, like, didn't they just announce something not too long ago? Yeah. So the mainframe has it, the Power 10 has it, and IBM machines into the future will surely have it. This is one of those, I think, amazing pieces of technology that will probably find its way into other products within a short amount of time. But so it's good that it's here with IBM. Additionally, with the transparent memory encryption, the memory modules, the DDIMMs themselves have chip kill technology, spare memory modules, you name it, right on chip or right on module. So again, really bringing the reliability of those modules to unprecedented levels. All right, I'm throwing this up there just because I love pictures. So this is a 2U DDIMM and a 4U DDIMM. These are the memory packaging that is available on the Power 10s today. 3200 megabit a second data rate with a total peak capacity of 409 gigabytes a second. That is amazing. 16 DIMMs per socket are supported, so you can imagine an enormous amount of memory capacity per machine. Let's talk about performance now. All right, here's a relative performance of a Power 9 system, or Power 10 system rather, compared to Power 9. So you can see this is really a big deal. Now, this is an older chart. I don't think I'd ever use this again because 2 weeks ago, quite frankly, the RPerf and CPW numbers were released. So you can look up all your favorite systems and what they perform like based on RPerf or CPW. But this just shows you that the Power 10 is really a no-joke chip. It is sometimes 3x. That's 3x more. More powerful than the previous machine. But in general, expect a 30% gain on RPerf. One thing I want to point out here I think is really neat is that DDR4 and DDR5 graph. You can see that DDR5, again, gives you a nice boost off over the DDR4. However, DDR5, quite expensive at this point, not in the product line today. Look for it, I'm not saying tomorrow, but shortly. One more benchmark just to make your eyes bleed. I promise this is it. No more after this. Here's an SAP Tier 2 benchmark comparing an Enterprise 1080 machine that was released last year to a competitive machine. And what I want to point out here is that 120 Power 10 cores destroys the 448 competitive cores in the competitive machine by quite a large margin. So the Power 10 core per core performance is very impressive compared to the competition. However, when you look at this, I think you have to look at it more of a holistic viewpoint. Number one, what is the software cost between these two? SAP has different varying software licensing metrics, right? So that's a big deal. And then, of course, what is the total system cost? And these systems are broadly comparable price-wise. So pretty impressive results, IBM. Let's keep it up. As far as systems are concerned, last year we debuted the Enterprise 1080 machine, and that's where that result you just saw came from. This year, 2 weeks ago, July 12th, we're debuting the rest of the product line. That means the scale-out systems in 2U and 4U form factors, and the enterprise-grade 4-socket system, the E1050. Let's take a look at what these guys look like. All right, this is a slide that everyone wants to see, right? These are what these machines will look like. The S1014, the very entry level on the machine stack here, is a tower system or rack mount system for you. 8 DIMM slots, 1 terabyte of memory max, although it does not support that that memory today. Upon release, IBM has only able to secure enough parts to offer half a terabyte memory configurations, at least at launch. We're told that we'll probably get the 1 terabyte memory later on this year, so Just hang with us here, folks. We'll get you there, I promise. The 1022S is sort of a scaled down version of the 1022. Really, in all of these, in the right half of the product line here, the 1022, 1024, they're dual chip modules per socket, right? And this 1022S is basically a single chip module per socket. And I'll show you exactly what that looks like in a bit. So it's a little bit cost optimized version of the other machines. 1022 or L1022. The L1022 is just for Linux. If you remember before, in the previous generation, we had L922s and 924s, that type of thing. They were just for Linux. They might even have used a different chip entirely, meaning that it was the supercomputer version of the chip. It was the SMT4 chip, basically half the computing resources. Well, we don't do that right now, at least with Power10. Power10, it's the same big fat chip that you know and love in the S1022, but you just get a big price break for running only Linux workloads on the L1022. And then the 1024 or L1024 with up to 48 cores and 8 terabytes of memory. The first system in the scale-out product category is the Power Systems S1014. So this is a system really built for the entry-level customer that needs either 4 or 8 cores, IBM I, AIX, or Linux, and up to 1 terabyte of memory. Although only 512 gigabyte right now is available at launch. And that, for a couple of my customers, actually is a little bit of a sticking point. They have large memory footprints with small core counts, so they're probably going to sit on the sidelines for a few months until that gets remedied. Again, with the 1014, you can see the same memory encryption technologies added. There are 16 NVMe U2 flash bays, and I want to make sure I spend a tiny bit of time on this. All of Power10 systems that you're going to see here, all of them rely on NVMe disk for storage. No more SAS disk, and the 1014 has the largest amount of internal storage of any of the machines here. A lot of customers will use the internal storage here solely, and no external storage, no SAN devices will be used on these machines. So that's why it has so many of those disks. You can use up to, I think, a 6.4 terabyte drive is the largest one we have today. 3.2, 1.6, and 800 gigabyte are also available. We can also see here the secure and trusted boot with TPM module. That's a trusted platform module. That's how we boot these machines now. Think of them as looking at the OS and the cryptographic keys of the OS and making sure it matches what's on the module in order for the system to boot. More security for you. All the systems in the product line support this now. A lot of competitive systems also support some form of TPM. All right. The one thing I do want to also mention, this is very important for some customers, is the 220 or 110 volt AC power supplies. This is the only product in the lineup that can accept 110 volt. So if you're sticking this in a closet, this is the only system you're going to be sticking in a closet. It's also available with a tower or a rack form factor. Let's take a look at what the server architecture looks like. Very simple here. You can see that the single socket has a P10 processor along with another die on the package itself, which is an I/O switch that switches between all your various I/O in the system, right? Which would be the Gen 5 and Gen 4 PCI Express slots. Only 8 DDR4 DDIMM slots available, but that gives you 1 terabyte of memory in total. This is a quick look of what the system looks like physically. So you can see the tower form factor and the rack form factor. The tower form factor, it always cracks me up when it has those little wings at the bottom to make sure the thing doesn't tip over. IBM, leave it to them to think of everything, I tell you. So, but it looks pretty handsome, I think. Anything I want to point out here? I don't think so. You can see the 16 NVMe U2 slots on the front of the chassis. That's your storage. Here's our processor options for the S1014, 8-core or 4-core. You can see the IBM P group there, which is important to a lot of customers. Just realize that the P05 group still has limitations when it comes to memory and hard disk space, at least internal hard disk space. You can have a total of 64 gigs of memory and a total of 6.4 terabytes of total disk. Really, that's 3.2 terabytes after you do a mirror of that disk. So realize if you have more memory or more capacity requirements than that, then we'll be looking at external storage for this particular box. Just one of the limitations. Don't shoot the messenger, okay? I'm just the guy telling you what it is. I didn't make it up. All right, let's take a look real quick at the internal storage. Here's our internal storage for this particular box. I talked to you a little bit about the drives, but I want to make sure I had a slide on it as well. In order to, if you had an 8-core version of this machine, if you needed more storage, whether it's IBM I or AIX or whatnot, and you do not want to use an external storage device like a SAN, then you can, of course, throw on a SAS-based RAID card with a SAS-based disk drawer. That's fine. Also, in the future, you'll be able to throw on more NVMe drives in an NVMe disk drawer, although that's not available here right now. So this is the last time you're going to see this slide. The disks are available in all the same disks are available in all the machines you're going to see from here on out. So I'm not going to show you this slide again. Here is a comparison between the S914 and the S1014, and the changes are in green. So obviously Power 10, OMI memory, much more memory bandwidth than the previous generation. Yada, 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 yada. Main memory encryption, important. So good job, IBM. Looks like a worthy successor. The next product in the product line is the S1022 and L1022. The L1022 is a Linux-only version of this particular box. It's the same box. It just has a firmware that restricts the OS level to only Linux, and therefore lowers the price, the cost of the box to you, the customer. So that's a pretty big value add if you're just a Linux user, a Linux on Power user. We upped the core count significantly compared to the previous model, up to 40. So that is quite a lot of cores, very large Power 10 cores. 4 terabytes max memory, 2 terabytes available at GA. And anything else I want to say here, remember that it's a 220 volt machine, so you better be plugging into the appropriate power. And then, of course, the very similar disk drives that you'd see in the previous machine. However, only 8 of them, not the total 16. Right? A lot of these machines are going to be used for, most of the workload will be on SANs at that point. And truth be told, a great deal of our customers even boot their IBM I environments from SAN. So if you've not seen an IBM SAN lately, stay tuned at the end. We're going to talk a little bit about it, but I think you should really take a look at them. They're quite cost competitive these days, and a great place to stick your data. All right, here is the system architecture. As you'd probably imagine, this is the dual chip module per socket, 2 full fat P10s per socket with a total of 16 DDIMM slots per socket. So quite a few expansion card slots here and memory card slots. If you see the purple acceleration ports up at the top, that will be for your memory memory inception. Let's try to get this right. Memory inception workloads, if you choose to use them, or any other accelerator cards that are available for these machines. And you know what? I'm scratching my head right now. I can't even think of one, save for the NVIDIA accelerators in the previous generation. So maybe there were some. I have no recollection of them. Here is the system design. It looks like a TU server, quite handsome one at that. Please pay attention of number 6. This is where the memory goes or is placed in the system. So you have 2 large banks in the front of the system, and then you have a couple of DDIMM slots right aside of the processor, which I find kind of interesting that they put them there. And of course, number 7 is the fully replaceable CPU VRMs. That's a voltage regulation modules. So if those go in the fritz, you can easily swap them out. Here are the processor options for this L1022 or an S1022. So we have per core or per socket, 20 cores, 16 cores, or 12 cores. As you can see, the smaller core counts have higher frequencies, and the larger core counts have lower frequencies. So therefore, you can see that this is either a max throughput or a max core or thread performance offering. I'm going to talk to you about a funny little server in the lineup here. This is the S1022S. What does that last S stand for? Gee, beats me, man. I don't know. The IBM folks have told me lots of different things. Maybe it stands for single chip module, simple, cost optimized. I don't know. different. Let's leave it at that. So think of it this way: it's a 2-socket server, but instead of a dual chip module, they really have a single chip module, sort of. I'll show you what that looks like. 2 terabytes of memory max and much lower total core counts. But for those customers that do not need larger core counts, that's fine. Also realize that the memory bandwidth is smaller because there are not as many memory channels per socket. So that's a consideration as well for those folks who are running very memory intensive workloads. This is what the server architecture looks like. P10 per socket, an I/O switch per socket. So it's sort of like a doubled 1014. Here are processor options. You have 4 cores or 8 cores, and that's it. So that's what it is. IBM P10 group. With the 4-core option, there is no IBM I support at all on this machine. So I've already had a few people say, hey, what if I can't get a terabyte of memory in a 1014S, or 1014 rather, can I get that in a 1022S? No, because you have to go up to the 8-core processor module in the P10 group. So no. Well, unless you want to go to the P10 group, that's fine. Then you can definitely do that then. Here's a comparison between the two machines. And let me just point out the peak memory bandwidth on the 1022S compared to the S1022. So 408 gigabyte a second on the 1022S, where the vanilla 1022 has 818 gigabytes a second of total memory bandwidth. Wow. So that's a machine I'd want for sure. All right. L1024. So this is the big guy, sort of. The big guy in the scale-out realm, right? The big guy in the 2-socket. It is a 4U machine. A 4U form factor will enable bigger and better cooling on the processors, so you'll see more cores and more performance, more frequency. So that'll be pretty exciting for some customers. Up to 16 NVMe U2 flash bays provide a whole bunch of storage, over 100 terabytes. So I guess this one is the other one that has 16 NVMe U2 bays. For whatever reason, I had it stuck in my head that the 1014 was the only one that did, but no, this one does as well. And this is what the machine looks like. Look at number 5, that giant heat sink they put in there. It will enable faster clock speeds for sure. I will say one other thing too. Number 8 is the eBMC. IBM is no longer using the flexible surface processor on the scale-out servers. We're using the baseboard management controller, the enterprise version of it. It's an open design, and it largely does everything the flexible surface processor does, so why not adopt it? And that's what IBM has done on all these machines. Here are processor options for this machine. Notice the P20 and P30 IBM P groups. So that's a little bit bigger than some customers are used to seeing. So 12 cores to 24 cores per socket. And this is the differences between the previous generation and the current generation. Again, I'm going to point out that memory bandwidth per socket, 818 gigabytes a second compared to the last one, 340. The 340 was a completely game-changing, world-crushing machine when it came out for these in-memory workloads. And boy, it's going to get crushed by the new generation. The new hotness is here, ready to crush it. So how great is that? All right, let's move on. 1050. And a lot of you folks are loving this machine. This is what I'm going to call an 8-socket. It's not really. It's a 4-socket machine, but with a dual chip module on each socket. That's where I say it's the world's best 8-socket server with up to 96 cores. You can order this one as little as 2 sockets populated, and then you could add another one later and add a 4th one after that. It also provides capacity upgrade on demand, the various mechanisms that we have at IBM to activate dark cores at a later date. Okay, this is what the machine looks like, chock full of goodies. You can see the 4 cores, where the DDIMMs go, and they are certainly an army of DDIMMs for sure. Anything else I want to say here? No, not really. Most of the time, again, we're going to use those 10 NVMe SSDs in the front. We will populate only 4 of them. Two of them will be used in a mirror for each VIO server. Here's our processor options and what we can do with this particular machine. So the 12-core processor, you have to, once you select a processor, you stick with that processor. So if you stick with a 12-core, you cannot then go to an 18 or 24-core processor. Just not going to work. So 12 cores yield a total of 48 cores in the system, or 24 cores yields a total of 96 cores. The one thing I'll point out here is that there is a healthcare-only solution edition, which lowers the cost of the system dramatically when used for just certain healthcare workloads. So that could be of interest to some folks, and it has been a big interest to a lot of our healthcare customers, of which there are quite a few. Okay, what's changing compared to the last generation, compared to this generation? 1,636 gigabytes a second. Wow. That's a lot of gigabytes a second for sure. In the 1050 compared to the 950. So big jump. Good job, IBM. Very worthy successor to the previous generation. I'm going to throw this up here as my prompt to remember to tell you, listen, if you're on AIX 5.3 or IBM i 5.4, yeah, you're not going to be using those OSs with these new machines. You got to get off those old OSs to something sort of current, right? So here is our compatibility matrix for Power 10 and Power 9. As you can see, Power 9 supports the entire gamut of OSs listed here, with the Power 10s needing certain base OSs like AIX 7.1, TL5, SP6, right? So that goes back pretty far. Looks like it's a virtual I/O only though. So if you're running non-virtual I/O workloads, that's not going to work. You got to get to VIO. IBM I looks like IBM i 7.3 TR11. So we're doing pretty good there. And RHEL 8.4. That should be no surprise right there. One other thing here is that you may need a new hardware management console. The newest ones, based on Power technology, the 7063 CR1s and CR2s, those are both supported. Anything before that, not supported. But the minimum level, I shouldn't say the minimum level, I should say, but let's try that again. But we do support the virtual HMC, which has been a big hit. So if you haven't seen a virtual HMC, maybe you should take a look at it. It's much less expensive than a piece of hardware, the hardware management console, to do the same thing. And it lives on, at least typically we'll have it live on VMware environments. So pretty good solution, I think. I mentioned this before, but I wanted to mention it again. IBM's transitioning from the flexible service processor or field service processor to the eBMC open platform for systems management, largely because the baseboard management controller BMC functionality of other servers has really matured over the years, and there's really not a reason for IBM to be investing and creating the flexible service processor really going forward. So that's what it is. I think they really had some good intentions here, and it worked out really well for them because they were able to reimagine how the usage of the BMC is with customers. So they rewrote some of the GUIs. If you've ever been to the ASMI GUI, that's all looking better, much better, with design thinking approaches to the design of the GUI and everything. It's a very easy to use management platform, right? So really, most customers, you won't even notice it. It's just the new hotness within Power that you're probably going to see a lot more of in Power 11 as well. All right, folks, we'll have some questions at the end, but I just want to give a quick plug for IBM storage. So what goes great with IBM Power 10 systems or any open workload? That means you, VMware. And the answer is clearly IBM storage. Okay, folks, if you haven't ever seen IBM storage, now's the time. But I'll be really quick. I'm going to give you really 3 reasons to consider IBM storage. Number 1 is this thing, the IBM FlashCore Module. IBM is now in the disk drive business, baby. Now, I know some people say, are they really making their own disk drives? No, but neither's AMD. They're not making their own microprocessors. They're getting them made at a fab somewhere in Taiwan, okay? IBM is now in the disk drive business. These things are amazing. IBM bought a company called Texas Memory Systems years ago for their intellectual property. Their intellectual property, they're making flash modules super reliable, resilient, and above all, fast. They've also recently added in a 2x minimum base compression in the data path to this module. It's an amazing achievement. So this one says at the label 19.2 terabytes. Really, it's almost a 40 terabyte minimum module. It may even see 3x the base nameplate capacity on this particular module. So you could even see up to 60 terabytes. These are the densest flash modules in the industry today, bar none, period. But it's much more impressive than that, I think, because there's a big zero right there spelled out, 0 of these have ever worn out in the marketplace. No other manufacturer can state that. And that's because of IBM's intellectual property when it comes to the FlashCore modules. The stuff in there, the guts, the way it works is much more advanced than those other guys than the industry standard sort of NVMe drives. And that's why IBM can very happily claim the 0 modules have never worn out. So love to show you more about these, but these things, since they're so amazing when it comes to performance and IBM sources them from themselves, they really have a pricing advantage over the rest of the market. And I think it really shows. Another reason you should take a look at IBM storage is the data resilience features. Now, there's a lot of stuff on here, such as multi-platform support, 100% data availability guarantee, 2 and 3 site options for replication, encryption, which if you're looking at a flash platform or a SAN that doesn't offer encryption, listen, folks, that's table stakes at this time in 2022. Run screaming away. The real innovation here is this thing called safeguarded flash copy, which offers logical air gaps of your data sitting on the SAN. So a flash copy or a snapshot is a data structure on the SAN that allows you to take a point-in-time copy of whatever your data is, whatever your volumes are. And a safeguarded copy is an immutable copy. That means you cannot delete it until the time period expires, and then it's deleted automatically if you so choose to delete it. So this helps you really with any concerns over ransomware or other threats of that nature. And at MAPSYS, we've even seen 6 or 7 ransomware attacks just over the COVID time period here in the last 3 years that have made our skin crawl. And it's no fun doing an incident response with a customer that's hurried trying to get their life back together, their business back together. So this is a way to really ensure and help you with that. And it's very, very low cost for the most part. Really, all you're going to do is buy a few more disks, a little bit more capacity to ensure you have space for your logical air-gapped copies, your safeguarded flash copies. So number 2, good reason. First one was FlashCore Modules. Second one is safeguarded copy. Third one is dollar. So I put the big giant dollars up there, and I also wanted to show you a little bit about what the current product line for the NVMe products look like. From the smaller system, the entry-level system, the 5200, to the mid-range, the 7300, and the very large system, the 9500. But really what it comes down to is if I were to show you what the price of these things are compared to what you're going to look at as competitive storage, we're going to win every time, or most every time, probably every time. I've never lost, let's put it that way. These systems are amazing systems. They're super fast. They never wear out. They're backed by IBM, and we've got a pricing advantage, quite frankly, compared to the rest of the industry, mostly due to those FlashCore modules. It's a wonderful 1, 2, 3 punch. Additionally, these systems are pretty advanced. Let's just say you set up with a 5200 and you say to me, DJ, I need more capacity. I don't want to use SAS-based technology to expand this thing. I want more NVMe goodness, plus I need more controller capacity because I have blah, 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 blah. Well, we can do that. We can cluster these systems together, and that's another way we can grow these things. So 2 5200s can go together, or up to 4 7300s or 4 9500s. Can be clustered together. So again, another great piece of the technology. But that's it. That's all I wanted to say. Those are the 3 things. If you're not going to take anything from the storage discussion, take only this. IBM's in the flash system game, the flash module game. They make their own modules. They're called IBM FlashCore. They have this awesome data resilience technology called safeguarded flash copy to help you protect yourself from ransomware. And The systems are super great, and they're going to be much more price competitive than anything else you're going to look at. So look at them. Those are 3 things. That's it. And with that, folks, ba-bam. All right. It looks like we landed this plane, folks. So, hey, thanks so much for sticking with me. I do appreciate it. As you can all tell, I have quite the passion for both IBM Power10. I used to be a designer back in the day, and IBM storage. This stuff is just really great. I think these products are built for your business. They can really be a game changer in your organizations. And you know what? MAPSYS can help you get there as well. We are a nationwide IBM business partner. We do a wonderful job. Our staff is dedicated to helping you, especially as an ESOP, an employee-owned company, to help you be the best you possibly can be every day at work and grow and prosper with IBM products. So with that, I'd like to say thanks again. And I do believe, Keith, that we have some time for questions. So I'm going to turn it back to Keith, and we can go from there. Thanks again, folks. I really appreciate your time.